Hello, calculus fans. All right, let's try to evaluate the integral of the square root of 25x squared minus 4 all over x dx. Now the thing to note is that the square root of 25x squared minus 4 is actually equal to the square root of the quantity 5x squared minus 2 squared. And that leads us to make an inverse trig substitution. Now it's going to be theta equal arcsecant of 5x over 2. And the way we know that is that this is the 5x, and here's the 2. And then the reason we know it's an arcsecant is because if we go back to the table will tell us that if we have a variable squared minus a number squared, that leads us to an arcsecant substitution. All right, so theta is going to be equal to arcsecant of 5x over 2. You want to have a triangle that relates x and theta. Now, just like we did in the last problem, we need to figure out what goes on the missing side. Why don't you take a moment to work that out? What is the thing that's going to go there? Go ahead, pause the video, do a little bit of algebra, work out what that thing is going to be. So we should get square root of 25x squared minus 4. It's very common for this sort of thing to happen. That's exactly the thing that showed up in the integrand. And that actually gives you a good reason why you want to make an inverse secant substitution, because it will work out so that one of the sides on your triangle will be that square root of expression that shows up in the integral. Okay, let's work out the rest of the pieces that we need. So secant theta is equal to 5x over 2. We've got that. So we can say that 2/5 secant theta is equal to x. Now let's take a derivative. Remember that the derivative of secant theta is secant theta tangent theta. So we've got 2/5 secant theta tangent theta d theta is equal to dx. Then, based on the picture, go back to the triangle, 2 tangent theta is equal to the square root of 25x squared minus 4. See what tangent theta is in the picture. So remember, SOHCAHTOA, you can figure out what tangent is using opposite over adjacent in your triangle. Okay, now let's put these things into our integral. So we know what each piece is, we can go ahead and make the substitution. Keep in mind that anytime you make a substitution, it needs to be wholesale. That is, all at once, you're going to transform the dx integral into your d theta integral, or whatever your new variable is. Right? We worked out what the square root is. The square root is 2 tangent theta. We worked out what x is. X is 2/5 secant theta. And we worked out what dx is. Dx is 2/5 secant theta tangent theta d theta. We're just taking each piece and making the wholesale replacement. All right, a little bit of algebra, and we now get 2 times the integral of tangent squared theta d theta. Now use your alternate Pythagorean identity. You can change this into secant squared theta minus 1. The reason this is useful is I don't know an antiderivative of tangent squared, but I do know an antiderivative of secant squared. It's just that easy, right? Antiderivative of secant squared theta will just be tangent theta. So our answer at this point is 2 tangent theta minus theta plus c. We cannot stop here. We made a substitution, so we got to change it back. We got to go back to x. Let me just remind you what the triangle looks like. It looks like this, and so remember that the triangle tells us specifically that tangent theta is equal to the square root of 25x squared minus 4 all over 2. That's using opposite over adjacent. That tells us how to make the replacement to turn tangent theta back into something with x's. Remember, we also know that theta is equal to arcsecant of 5x over 2. You might say, well, okay, now how do we know that? How do we know that theta was arcsecant of 5x over 2? We made that. We made theta equal to arcsecant of 5x over 2. That was our original substitution. Okay, that's it. Here's our final answer. 2 times the quantity square root of 25x squared minus 4 all over 2 minus arcsecant of 5x over 2 plus c. I'm not doing anything further with this, so I'm not going to bother to simplify anymore. Okay, that's all for now.